In this question, it is given that let psi1 takes the interval this to r, psi2 takes the interval this to r, f takes the interval this to r, and g takes the interval this to r be functions such that these are defined. This is the definition of psi1x, psi2x, fx, and gx. It is also given that f0 is equal to g0 equal to 0. And you have to find out of these choices which one is correct. And next question for the same paragraph is you have to find the correct choice out of these. Note that for this paragraph question, it is given in the beginning that out of these four, only one choice is correct. And similarly, out of these four, exactly one is correct. And because in this exactly one choice is correct, therefore in this type of questions, it is always best to start checking from the easiest one. It's clear that A seems to be the easiest one. Slightly more difficult than A is D, then slightly more than D is B, and slightly more than B is C. Therefore, I'll be checking the choices in this order. First, I will check A, then I will check D, then B, and then C. Actually, this is only my idea that in this order of increasing difficulty level. I may be wrong also. Exactly, I can say only after doing the question. First of all, to find the value of f of under root log 3 plus g of under root log 3, it is clear that fx plus gx is equal to minus x to x mod t minus t square into e to power minus t square dt plus 0 to x square under t e to the power minus t dt. The integrand this is clearly a even function. Hence, I will say this is equal to 2 times 0 to x mod t minus t square and e to the power minus t square dt plus 0 to x square under t e to the power minus t dt. According to the information given in the question, x everywhere is positive. Hence, when t varies between 0 and x, mod t will become t, and therefore I will be getting 0 to x t minus t square e to the power minus t square dt plus 0 to x square under t e to the power minus t dt. It's clear that this part of the integral can be done easily. Minus 2 times 0 to x t square e to the power minus t square plus 0 to x square under t e to the power minus t dt. It is also clear that if I take t equal to y square, I'll be getting the value of this in this form. Therefore, I'm calculating it separately, and after calculation, I will put it back. Clear that by taking t equal to y square, dt becomes 2y dy, and I get 0 to x, and here y e to the power minus y square 2y dy. This is equal to 2 times 0 to x y square e to the power minus y square dy and using the first property of definite integral, just changing the name of variable makes no difference. Therefore, I can write it as 2 times 0 to x t square e to power minus t square dt. Hence, I have got the value of this in this form, and this are same. Therefore, I can say this and this will get cancelled. And for doing this, let t square equal to z 2t dt equal to dz. Therefore, I'll be getting 0 to x square e to power minus z dz. That is, I get e to power minus z upon minus 1 0 to x square. That is, I get minus e to power minus x square minus e to power 0. That is 1 minus e to power minus x square. That is, I have got the value of fx plus gx as 1 minus e to power minus x square. Therefore, f of under root log 3 plus g of under root log 3 is equal to 1 minus e to power minus log 3. That is equal to 1 minus e to power log of 1 by 3 equal to 1 minus 1 by 3 is equal to 2 by 3. But in this choice A, the answer is given as 1 by 3. Therefore, this becomes a wrong choice. As I told you in the very beginning, because it is given that only one choice is correct, therefore I'll be checking easiest choice to toughest choice in this order. It seems to be that D is the next tougher. In this choice, he is asking f is an increasing function on the interval 0 to 3 by 2. For this, I will find f dash x. But before f dash x, first I will write it as 2 times 0 to x t minus t square e to power minus t square dt. This equal to this I have just now proved. From here I can say f dash x is equal to 2 times x minus x square into e to power minus x square. That is equal to minus 2 into x minus 1 into e to power minus x square. As in the question, we had to discuss the monotonicity in the interval 0 to 3 by 2. In the interval 0 to 3 by 2, this whole can be positive also and negative also, because for x between 0 and 1, this whole will be positive. For x between 1 and 3 by 2, this whole will be negative. Therefore, I can say f dash x in this whole interval can be positive also and negative also. Hence, I can say in this interval, f is increasing also and decreasing also. Hence, I can say D choice is wrong. And now, let us check the choice B. For the choice B, we have to check that for every x greater than 1, there exists an alpha belonging to the interval 1 to x such that this is equal to this is true or not. And now putting the value of psi 1 x as e to the power minus x plus x, this can be written as e to the power minus x minus 1 is equal to alpha minus 1 into x. And because in the question it is given that x is greater than 1, hence the value of this is sure to be negative. And because alpha is more than 1, hence the value of this is sure to be positive. Hence equality is never possible. Hence the given statement of choice B is wrong. I have got the conclusion so far that B is wrong, D is wrong. Hence, obviously, C becomes the correct choice. But still, for clarity purpose, I'll be giving you the solution of C part also. To check this thing means I have to check x square minus 2x minus 2 e to power minus x plus 2 is equal to 2x into psi 1 beta minus 1 for at least one value of x in the interval 0 to x is true or not. That is, I have to check e to power minus beta plus beta minus 1 is true for at least one value of beta in the interval 0 to x is true or not. That is, I have to check that is, we have to check this is true for at least one value of beta in the interval 0 to x is true or not. That is, I have to check this is true for at least one value of beta in the interval 0 to x is true or not. And this can be written as that is, I have to check this is true for at least one value of beta in the interval 0 to x is true or not. And this is clearly true. With the help of Lagrange's theorem, I can say if I take a function hx as x square minus 2 e to power minus x plus 2 and take the interval 0 to x, then according to Lagrange's theorem, there is at least one value of beta belonging to the interval 0 to x such that hx minus h0 upon x minus 0 is equal to h dash beta. And you can see very easily h dash beta is equal to this because h dash x is 2 e to power minus x plus 2x, hence h dash beta will be 2 e to power minus beta plus 2 beta. Hence I can say C is the correct choice. Again, in this question also it is given that only one of the choice is correct. Hence the best will be start checking from the easiest one. These two seems to be easier one, and out of these two this will be more easier because in the definition of psi 1x this is given and in the definition of psi 2x this is given. To check this thing means we have to check that e to power minus x plus x is less than equal to 1 for all x greater than 0 is true or not. It is obviously wrong if I take the value of x more than 1. Hence I can say A is the wrong choice. Now I have to check that x square minus 2x minus 2 e to power minus x plus 2 is less than equal to 0 for all x greater than 0 is true or not. Actually it can be written as x into x minus 2 plus 2 into 1 minus e power minus x. It is clear that if I take the value of x very large, this will be positive, this will be positive, hence the sum will be positive. Therefore the statement that psi to x less than equal to 0 for all x greater than 0 is wrong. Hence I can say B is wrong choice. And out of C and D, both seems to be equally difficult. Hence I check any one first. Say I check this thing. For checking this thing, I have to check that fx minus 1 plus e to power minus x square plus 2 by 3 x cube minus 2 by 5 x power 5 greater than 0 is true for all these values of x or not. Let us name it as, that is, I have to check that for all x lying between 0 and 1 by 2, this is greater than 0 is true or not. It is clear that h0 is equal to 0 because f0 is 0. Hence I can say if h dash x is found to be greater than 0, it will mean that for x greater than 0, hx will be greater than h0 and this is 0. Hence it will mean that hx is greater than 0. This is a procedure I am going to use. This will become surely correct if h dash x is found to be greater than 0 for these values of x. It is clear that h dash x is equal to f dash x minus 2x e to power minus x square plus 2x square minus 2x to the power 4. And f dash x I have already found in the previous choices was f dash x equal to 2 into x minus x square into e to power minus x square. Hence I have to check 2 into x minus x square e to power minus x square minus 2x e to power minus x square plus 2x square minus 2x power 4 is greater than 0 for these values of x or not. That is, I have to check whether this is positive for these values of x or not. This is equal to minus 2x square e to power minus x square plus 2x square minus 2x power 4. And because everywhere even power of x is there, for simplicity let x square equal to t, and I take 2 common also. I get 2 into minus t e to power minus t plus t minus t square. That is, I have to check the sign of minus e to power t plus 1 minus t. This is equal to 2t minus e to power minus t plus 1 minus t. And now note an important thing which I am going to tell you. In the expansion of any function, here it is e to power minus t. I am going to use the expansion of this. In the expansion of any function, if the terms are alternately positive and negative, just like in this case, here the expansion is 1 minus t plus t square by 2 factorial minus t cube by 3 factorial and so on. Remember this thing that the value of e to power minus t is sure to be less than 1 also. 1 minus t plus t square by 2 factorial, the value of this is less than this also. The value of this is less than 1 minus t plus t square by 2 factorial minus t cube by 3 factorial plus, here I have gone up to t square, here I have gone up to t to power 4. I can go up to t to the power 6 also. The value of e to the power minus t will be less than all these. Similarly, the value of e to the power minus t should be always greater than 1 minus t, greater than 1 minus t plus t square by 2 factorial minus t cube by 3 factorial, and also greater than 1 minus t plus t square by 2 factorial minus t cube by 3 factorial plus t to the power 4 by 4 factorial minus t to the power 5 by. Here you can see very easily I have gone always up to odd power of t. This is true for all positive values of t. I am saying positive because for positive values only this is alternately positive and negative. Therefore, for all positive values of t, this will be less than this all, and the value of this will be more than this also, and so on. You have to remember this thing, and from here I can say this is a negative number. Hence, as a whole, it is a negative number, and actually this is true for all positive values of t. And here x was belonging to 0 to 1 by 2, therefore x square will be belonging to 0 to 1 by 4. Therefore, for t lying between 0 and 1 by 4, this will be negative. Hence, I can say s dash x is negative. That is, I can say hx is decreasing function. Hence, if x is greater than 0, hx will be less than h0, and h0 is 0. Therefore, the value of this will be less than 0. Therefore, the value of fx will be less than this. Therefore, C is wrong choice. And now, obviously, D becomes the correct choice. But still, for clarity purpose, I will check the choice D also. To check this thing means I have to check for these values of x, 2 by 3 x cube minus 2 by 5 x power 5 plus 1 by 7 x power 7 minus gx is greater than equal 0 or not. For checking this, let us name a function sx as 2 by 3 x cube minus 2 by 5 x power 5 plus 1 by 7 x power 7 minus gx. It is clear that s0 is equal to 0. If I find that s dash x is less than 0, it will mean that sx is a decreasing function. And if sx is decreasing, it will mean that for x greater than 0, sx will be less than s0. That is, sx will be less than 0. I will get this conclusion, and if I find that s dash x is greater than 0, it will mean that for x greater than 0, sx will be greater than s0, and s0 is clearly 0. Hence, I will get the conclusion that sx is greater than 0. That is, I will get the conclusion that this is greater than 0. That is the main point now, is to be check the sign of s dash x. It is clear that s dash x is 2x square minus 2x power 4 plus x power 6 minus g dash x. That is, this is equal to 2x square minus 2x power 4 plus x power 6 minus. Recall that in previous choices I have already proved that g dash x is 2x square e to the power minus x square. Hence, I will get here 2x square e to the power minus x square. And now because even power of x are there, let x square is equal to t, and I have to check the sign of s dash x. I get it 2t minus 2t square plus t cube minus 2t e power minus t. That is, I have to check the sign of 2 minus 2t plus t square minus 2 e to power minus t. As I just now explained that the value of e to power minus t is less than 1, and 1 minus t plus t square by 2 factorial and 1 minus t plus t square by 2 factorial minus t cube by 3 factorial plus e to power 4 by the value of e to power minus t is less than all these, and I take care of this. And as e to power minus t is less than 1 minus t plus t square by 2, therefore 2 e to power minus t is less than 2 minus 2t plus t square. Hence I can say 2 minus 2t plus t square minus 2 e to power minus t is greater than 0, and t is already positive. Hence I can say s dash x is greater than 0 for all values of x. Hence sx is sure to be a increasing function, and therefore if x is greater than 0, sx will be greater than s0, which is 0. Hence I can say this is greater than 0. That is, the choice becomes correct choice.